The 3 Mile Island accident occurred on March 28, 1979 in Pennsylvania, USA, and is considered one of the most significant nuclear accidents in history. The incident involved a partial meltdown of Reactor Unit 2, which was caused by a combination of equipment failure, flawed system design, and poor operator response. Although there were no immediate fatalities, the release of radioactive gases triggered widespread public fear and led to major policy changes in the nuclear industry. This case became a landmark example in engineering ethics and safety, showing how technical and human factors can intersect to create a major crisis. It highlights the crucial responsibility engineers have, especially in high-risk sectors, to ensure public safety and uphold professional integrity at all times. Understanding this accident helps us learn valuable lessons about design, operation, and ethical accountability that remain highly relevant today.
Moving on to the brief overview of the incident, on March 28, 1979, a major accident struck the 3 Mile Island nuclear plant. A valve in Unit 2 malfunctioned, causing overheating and a partial reactor meltdown. The relief valve stuck open, letting coolant escape and exposing the core, which began to melt. A small amount of radioactive gas was released, and investigations found design flaws and operators' error. In response, the nuclear industry enforced stricter safety rules, better training, and improved emergency protocols, which driven by the lessons learned from the incident. Moving on to the significance of the incident, where it can be divided into three parts as shown in the slides. The 3 Mile accident triggered public panic and eroded trust in nuclear energy, and poor communication and media coverage worsened the fear, prompting mass evacuations. In response, the government strengthened safety regulations and emergency protocols. The incident also sparked a major anti-nuclear movement, slowed plant construction, and reshaped public policy. It remains a key case study in crisis management and nuclear ethics.
Let's move to the technical issue that occurred during the 3 Mile Island nuclear incident in 1979. There were 4 key technical lessons, but I will focus on one and show how it relates to our engineering practice here in Malaysia under the REA 1979. The most critical lesson is engineering competency and licensing. The crisis began with a start valve, but what escalated it was the operator's poor understanding of how the system behaves under abnormal conditions. Their misjudgment led to decisions that almost caused a full reactor meltdown. This is exactly why in Malaysia, Section 7(1)(a) of 10 and 10(d) of the REA only permit professional engineers with a practicing certificate to perform and lead high-risk engineering tasks. Looking back, every technical failure in the TMI incident, competency, ethics, design and regulation is addressed in REA to protect public safety and uphold the integrity of profession. It reminds us engineering is not just about solving problems, it's about bearing responsibility.
The 3 Mile Island nuclear accident in 1979 is a major case of ethical failure in engineering. First, the plant operator GPU failed to provide proper training. A stuck valve caused a coolant leak, but confusing control room data led staff to make it worse. They focused more on regulatory approval and cost saving than safety. Second, the Nuclear Regulatory Commission knew about design issues but didn't act. They allowed the plant to operate with unresolved risks, favoring legal compliance over public protection. Third, during the crisis, both GPU and the government delayed accurate updates. This violated the public's right to make informed safety decisions. Overall, TMI, or the 3 Mile Island, show poor ethics in design, regulation, and communication can turn a small fault into a national emergency.
Moving on to the recommendation to prevent future nuclear accidents like the 3 Mile Island incident. First, on the technical side, the accident revealed critical equipment failures and poor instrumentation. We must adopt passive safety system and ensure real-time monitoring of core parameters like coolant levels and temperature. Second, human error played a major role. Operators misinterpreted signals and worsened the situation. To address this, we need simulation-based training and better control room design focused on human factors. Third, from a regulatory perspective, the accident showed weak oversight. Moving forward, we need stricter inspection, transparent reporting system, and a strong safety culture where communication and accountability are prioritized. Lastly, the response to the accident lacked coordination. We must have clear emergency plans, regular drills, and public education to reduce panic and improve response during future incidents. In short, combining better technology, training, regulation, and preparedness can significantly reduce the risk of future nuclear accidents. Thank you.
In conclusion, the Three Mile Island accident highlighted critical failures not only in technical design but also in human decision making and regulatory oversight. It emphasized the importance of ethical responsibility and prioritizing public safety in all engineering practices. The case also showed the urgent need for a stronger safety culture and more comprehensive training programs for operators and engineers. Furthermore, it reinforced the engineer's duty as outlined in the Engineers Act to always uphold integrity and act in the best interest of society. Overall, the lessons learned from this incident serve as valuable guidance to prevent future accidents and help rebuild public trust in engineering and technology. By applying these lessons, we can work towards a safer and more responsible future for all.